I am Pankaj Sharma from Brain League Learning. Today we will build an intuitive picture for wavefronts. We will see them in water ripples, connect them to the direction a wave travels, compare spherical and plane wavefronts, and finish with Huygens' principle. Imagine dropping a small stone into a calm pond. Circles of ripples move outward. Each bright circle you see is a wavefront. It connects matching parts of the wave, like the crests. In physics language, every point on a wavefront is at the same phase. That means all those points are doing the same thing at the same time. For example, all at the highest point together. Now, how do wavefronts move? The direction the wave travels is always perpendicular to the wavefront. We often draw arrows called rays to show this travel direction. So, a ray is perpendicular to the wavefront. Wavefronts come in common shapes depending on the source. Spherical wave fronts appear when waves radiate from a single point source, like a tiny bulb or a pebble in water. In our top view, they look like expanding circles. Plane wavefronts appear when the source is very far away. The huge curvature looks almost flat to us, so we draw them as parallel straight lines. A powerful idea about how wavefronts move is Huygens' principle. It says every point on a wave front behaves like a tiny source that sends out its own small circular wave, called a wavelet. If you look at the envelope that just touches all these tiny wavelets, you get the next wavefront. So, the new wavefront equals the sum of all tiny wavelets. To summarize, wavefronts connect matching parts of a wave and share the same phase. Rays show the travel direction and are perpendicular to the wavefronts. Spherical wavefronts come from point sources, while plane wavefronts come from faraway sources. And Huygens' principle tells us how the next wave front forms from lots of tiny wavelets. Thanks for learning with me. Keep building intuition first, and the equations will make perfect sense